Good morning, guys. We're going to go ahead and finish the last lesson in this unit, solving exponential equations. So I'm going to do this first page with you and kind of show you what's up, and then the second page will be practice for you, right? So if you check out this equation, this is kind of different than anything that you've seen before because the x's are in the exponent, which is what makes it an exponential. There's kind of a really cool strategy when you go to solve these exponential equations. And the strategy here is you want the two bases of the exponential to be the same. So if you have a base equal to another base, sorry, you can't do that. Whatever is in the exponent up here has to be equal to whatever is in the exponent up there because they have the same base. So for example, this one, they both have a base of 6, which means that in order for these two to be equal, this exponent has to be equal to this exponent. So there's a property out there that says, all right, hey, two bases are the same, then their exponents must be equal, and we can write an equation with those two equal exponents. Now this equation, I know y'all can solve, so you just go ahead and combine your like terms, right? Subtract 3, divide, so we would have -3 over 5. The nice thing about these is there's no checking that you have to do, assuming that you did all the correct calculations. When you put -3/5 in for both x in both exponents, you will get the same value there. All right, so here's the next one. Same thing, they both have the same base. So when they both have the same base, you can go ahead and put their exponents equal to each other. Once again, this is not too bad of an equation to solve. So put your like terms together. Divide 2 divided by -6, that's -1/3. You should simplify those, by the way. Don't leave -2/6 on your paper. So -1/3, and when you plug that in, no need to worry about checking. It will work assuming that you didn't make any arithmetic mistakes along the way. All right, these do get harder, obviously. So here's the next one, and we're going to use this same property that we want to get both bases to be the same so that we can set their exponents equal to each other. And so right now I have 5 to a power, and then I have 625. And it might not jump out at you, but 625 is actually 5 to a power. And so you're probably going to need a calculator for this lesson as well. And I'm going to show you on my calculator, I just typed in 5 to the power of 4, and 5 to the power of 4 is 625. So there's going to be kind of this element of like guess and check to try to change some of these numbers into bases with powers. And so you could try 5 to the power of 3, 5 to the power of 2, 5 to the power of 5. Check all of them until you find the right one. Why did I do base 5 and not a different base? Well, because this one is base 5. So I want it to match. So I'm going to get rid of the 625 and instead write something that's equivalent, which is 5 to the power of 4. All right, once you have that, now you have two bases that are the same, so you can go ahead and set their exponents equal to each other, and then just solve. All right, here is another one, still base 5. They won't always be base 5, but still another one base 5, and this one is 1 over 25. And we've talked about what happens when we end up with a fraction to the exponent. So you should recognize the 25 as 5 to the power of 2, but because it's a 1 over 25, that means that the 2 had to be a negative. We talked about this a lot when we went to graph these equations. So if you're not really sure, let me know and I can kind of talk you through that again. So we're going to get rid of the 125 and put 5 to the -2nd. You can always check it in your calculator as well. And then when you get your decimal, you can check the other one, 1 over 25, and you get the exact same decimal. So that's how you know that they would be equivalent. All right, so once you have the same base, set the exponents equal to each other. So in this case, x has to be a +2. All right, once again, they still can get just a little bit harder. So here's the next one. I have 3, a base of 3, another base of 3, and then a 27. And the 27 can be written as 3 to a power. So check it out in your calculator. 3 to what power is 27? Well, I know 3 squared is 9. 3 cubed has to be 27. Now the problem here is that instead of just having a base equal to a base, and I can set the exponents equal to each other, on this side I actually have 2 bases. And so even though they're the same, you can go ahead and combine them together. So you can say this is 3 to the negative x, and then you add those bases together. Whenever you have two things being multiplied, two bases being multiplied, you can add their exponents. There's a rule from Algebra 1 that you learned. And then now you have 3 to a power equals 3 to a power, and you can go ahead and say that those two powers are going to be equal. I'm going to combine those like terms as I rewrite this as well. And then just continue to solve. So x would be -2. Once again, you don't have to check for any extraneous solutions. You can just go ahead and as long as you think you did your work correctly, you should be fine. If you want to check, that's fine though. Absolutely, you can go check, but you don't have to. All right, so here's another example of this. Instead, these though are base 9. So base 9 times base 9 means you can write it as 1 base 9 and add your two exponents together. So as you add those together, go ahead and just combine your like terms. And then 81 is 9 to the power of 2. So this would be 3r plus 5 equals 2, because now we have two bases that are equal to each other. Finish solving, we'd have 3r equals -3, so r is -1. All right, once again, they do get more complicated, so let's go ahead and check out the next set. Here we have the same base of 8, but in this problem, they're being divided instead of being multiplied. And so when you multiply two things, two bases together, you add their exponents. When you divide, this is going to be a subtraction, and that's also a rules of exponent that you learned in Algebra 1. So on this side, you're going to have 8 to the power of, and you're going to subtract these. Now remember, when you subtract the 1 minus 3m, you have to subtract both the 1 and the 3m. So the 1 becomes a negative, but the negative 3m will become a positive because you're subtracting both pieces. All right, and then on this side, we have to manipulate the 64. Well, 64, that's 8 squared. And so now I have 8 to a power equals 8 to a power, so I can say those two powers are equal. And you can go ahead and combine some like terms as you write them down as well. So I added the m's together. So m has to be equal to 3. All right. Next one, very similar. We have a base of 2 and a base of 2, and they're being divided. So you're going to subtract their exponents. So minus 2v. Notice that I didn't change any signs of the terms on the top. It's just the signs of the terms on the bottom that are getting subtracted. And then this one, 1 over 32, this one's going to take a moment. So let's see if we can figure it out. So 2 to what power is 32? Maybe 4, no, not 4, 5. 5. So 2 to the 5th power is 32. Now because this is 1 over 32, this is going to be 2 to the -5th. That's how it turns into that fraction. And now that you have a base equal to a base, and those bases are the same, you can go ahead and set their exponents equal to each other. So combining these terms, we'd have -v minus 1 equals -5. -v equals -4, which means that v equals a positive 4. And if you want, you can go ahead and check in here, and you should get that whatever number you have on the side is equal to 1 over 32. All right, still getting a little bit harder here. we have 25 to the 3x equals 125 to the negative 2x. And in terms of getting these to be the same base, 25 can't turn into a 125. You always want to pay attention to the smallest one. Can the smallest one be the 125? The best you could do here is 25 squared, and 25 squared is 625, and so that's not going to be that 125. So the problem is that 25 and 125, neither of those are going to be the right base for this problem. So instead, we're going to have to change them to a different base. So there's actually a number that when you raise it to a power, you get 25, and you raise it to a different power, and you get 125. And hopefully, you feel okay saying that 25 is 5 squared, and 125 is 5 to the power of 3. And so instead of just changing one of the sides into the base, you might have to change both sides into a different base. And that base that you change both sides into will always be a smaller number. That kind of will maybe help you try to figure out what one of those bases are. So the question is now is if this 25 is 5 squared and I have another power of 3x, what do I do with the 3x and the square? Because now they're both in the exponent. And when they're both in the exponent, in this case, when you have a power being raised to a power, the rule is to multiply those two powers together. So on this side, it'll be 2 times 3x, and then on this side, it'll be 3 times a negative 2x. Put that one in parentheses. And when you get a power raised to a power, you just multiply your powers, and now we have the same base. So we can go ahead and say this side, which is 6x, equals negative 6x. And continuing to solve this, solve it like a normal equation. Sometimes we get that there's just x's, there's no constants, and we kind of freak out a little bit. Don't do that. Just add 6 to this side, and then that means you have 0 left over. And then when you divide by 12, you'll have x's equal to 0. So the only number that makes these two the same, this side equal to this side, is 0. All right, another one similar to that. We have 81 and 243. And so I know 81 is 9 squared. So let's check if 243 is maybe power of 3. 9 to the power of 3. So I'm going to go ahead and show you my calculator. 9 to the power of 3 was 729. So that's not it because I'm trying to get 243. So the problem here is the very obvious 9 is not going to work. So we need a different number that we can raise to a power to get 81 and 243. And since we were talking about 9, think about the number 9. 9 is also a perfect square. And 9 square root is 3. And so 81 is also 3 to a power. So if it's 9 to a power, it's also 3 to a power. So I'm going to think it's 4, yeah. So 3 to the 4th power is 81. And then 3, we can check 3 to the maybe power of 5. 3 to the power of 5 is the 243. So at first glance, you might have thought that the common base we needed to turn them into is both 9. But in this case, it's actually both 3 because we couldn't get the powers to work out. So this is 3 to the 4th, and this side is 3 to the 5th. And then what do you do with the 4th and the 5th and the powers that were already there? Well, we multiply them. That's the power to a power rule. And so now we have the same base, so we can go ahead and set those exponents equal to each other. I'm going to distribute as I do that. And then just continue to solve. So this will be 22n equals negative 5. So n is negative 5 over 22. All right, I have 2 more, and they are even slightly more complicated. They take all of the properties that we've been talking about and put them together into one problem. So we have 1/5 times 125 to the negative v equals 25 to the 2 minus 2b. And so strategy is still the same. You want to turn it into a base equal to another base, and then that way you can go ahead and set their exponents equal to each other. So we have some manipulating to do here. First thing that I'm thinking is that maybe a base of 5 would be good for all of these. Even this one, the 1/5, you want to change it to a base of 5. So the 1/5, that's 5 to the negative first, and we talked about that a lot when we were graphing. 125, that's 5 cubed. And if you already have a power up there, when you change it, you have to multiply that power. And then 25, that's 5 squared. And so that will also get multiplied by the exponent that's already up there. All right, so now I have a bunch of bases of 5, but I still have to get just 5 equal to 5 in terms of the bases. So I need to put these two together. If they're being multiplied, the two bases, you're going to add these exponents. So this is 5 to the negative 1. That'll be minus 3b when you multiply it. And then on this side, 5, I'm going to go ahead and distribute as well. And so now we're set up like pretty much just like problem 1. We have 5 to a power equals 5 to a power, so you're good to go ahead and say those two powers are equal. And then just continue to solve. So I'm going to add the v's over there, add the 1, so we have v is equal to 5. So we had talked about all of the properties we used in this problem before, but we're just kind of throwing them all into one big problem where you just kind of have to pay attention to all the little details. All right, last one. Similar to this previous problem where we just have a bunch of rules that we'll have to apply here. The goal is to get them all to be the same base. Since I see the 36, I'm immediately thinking 6 squared, so let's check 6 to maybe the power of 3. That's the 216, so I know 6 is the good base to go with. So we're going to go ahead and change everything to base 6. So this 36 would be 6 squared, and then it already has a power, so times by negative b. In the denominator, that's 6 cubed, and it already has a power, so make sure you multiply those. And then on this side, 36, that's 6 squared, but since it's a 1 over 36, it'll be a negative 2 instead of a positive 2. All right, now that I have them all base 6, I'm going to go ahead and combine the fraction together. Because they're both base 6, you can subtract their exponents. So this will be 6 to the power of, and I'm just going to write it out. This is negative 2b, and this would be a negative 9b, but we're subtracting them, so that is actually going to change to a plus 9b. 6 to the negative second. And then your two bases are the same. There's nothing else going on, so you can go ahead and set your exponents equal to each other. So 7b equals negative 2. So we have b equals negative 2 over 7. All right, so your assignment for this lesson is the next page. So just some more for you to practice. So working through these next, I think there's 14 here. 14 questions, 16 questions. Let me know as you're working if you have any questions, anything you need help on, and we'll turn this in on either Monday or Tuesday when I see you next. And then next week we'll work on the test review and take the last test of the trimester. So as always, let me know how I can help.